Okay, let's continue with the Product Template Studio demonstration. Here is a mounting plate inside of NX, and currently this mounting plate does not have any Product Template Studio intelligence embedded inside. And I know this by looking at the icon that represents the mounting plate in the Assembly Navigator. Currently it's just a regular block that will change once the plate goes through the Product Template Studio. So let's go ahead and start the application. And here I'm starting the application inside of NX, but it doesn't have to be the case. You can also start the Product Template Studio as a standalone application. So when you come in, this is the interface that you will see. On the right hand side are various information tabs that will give you specific information about the template that you're about to build. So the first tab gives you information on what part you're working on. The next tab gives you access to all of your parts on your computer. And the third tab gives you a preview of the part itself and also all of the features and expressions and curves that went into building this part. Finally, you have a preview of the interface that you're going to build on the fly. And so this is where you can see what the interface is going to look like before you accept it. So let's go ahead and start to build our dialog. So we're going to come in here and start with a group. And you can see that without any kind of programming experience, I can go ahead and easily drag in a new group, and I'm going to label this group something more descriptive, such as bracket configuration. And so now as the designer, I can go ahead and choose which parameters I want future users to be able to modify. And so I understand that this block this mounting plate will be used to basically mate with different motors, right, and different interfaces within a subassembly. And so to me, as the designer, the most important expression will be the height. And so I can go ahead and just drag in the height parameter and have it available for everyone to modify in the future. And so you can see here that the height parameter is available, and let's go ahead and give it a more descriptive name. And this height parameter is going to be a linear dimension that will immediately update, and we can also specify origin points and origin vectors of where the modifications will start to take place. So once we have this done, basically the parameters are set, and now I can go ahead and come over to the requirements tab. This is where I can specify some kind of validation check for this bracket system, right? So as the designer, I know that I need a minimum requirement of 100 millimeters, otherwise this part will start to fail. When it goes below 100 millimeters, the mount holes will start to merge together, and the validity of the original design intent is no longer met. So let's go ahead and put in a minimum requirement. And we're going to have this minimum requirement fail if the condition of greater than 100 millimeters is not met. And so we have different options as well, right? As I stated earlier, you can have it fail, you can have it warn, or you can have it provide further information to the user. And so let's go ahead and also include some information. So we'll say that the minimum height has to be greater than 100 millimeters. And now that we have this as a requirement, let's go ahead and provide it as an external input from the user. And so now that we're done, we can go ahead and just publish this information. And now anyone who has access to where we're going to place this template will have access to the part itself. So when we come back to NX, we have to go ahead and restart the part, reopen the part so that it has the embedded intelligence inside. And once we do this, you'll see that the icons will change. And so now there is a light bulb next to the block, and so this represents that the mounting plate has some kind of reusable component inside. So let's go ahead and right mouse button to edit the reusable component. inside of this dialog, you'll see that this is exactly what we built on the fly just a minute ago, right? So now you can go ahead and see that the users can immediately update the part, and we had a minimum requirement set in our part, where if the height goes under 100 millimeters, then the part is going to fail. And so you can see that the holes start to merge together, and the original design intent is no longer met. So let's go ahead and see what happens when the user accepts this value. When they accept this value, they're going to have a error message that returns, and so the user can come in here and check the information. They'll see that the minimum height has to be greater than 100 millimeters, and so this will alert them that they have to know that they have to come back in and modify this part again. So now they're going to bring it above 100 millimeters, and then everything should be okay. So let's go ahead and see what happens inside of an assembly. So for example, let's go ahead and go over to this subassembly here, and here you can see the bracket used as a mounting plate for the motor and also the subassembly itself. And in this current configuration, the spacing allowed for this motor is specific to this motor alone. So what happens in future iterations when you want to have a more robust belt drive? So it's possible that you're going to have a bigger motor, and so what happens to the spacing that is allowed for this motor? So let's go ahead and see what happens if we substitute this in for a motor that's a little bit larger. So if we pick this motor here, you can see that the spacing allowed for the original motor is no longer valid for this motor. And so what do you do in your company at this point? So you either have to go back to the drawing board and find a motor that is of the same size but also retains a more powerful motor, or you can go with this motor and have the engineers who designed the bracket modify it so that it can be stretched to include spacing for this motor. And so now I can go ahead and modify this if the Product Template Studio Intelligence was embedded inside, and go ahead and edit the reusable component on the fly without contacting my original engineer. So the original design intent of the bracket is maintained, and I can go ahead and change this on the fly and have it retain all of the key parameters that it had to remember. So all of the mount holes to the subassembly and the mount holes to the motor remains intact, and so this is a part that I can currently use in my subassembly revision. And so this is something that's very powerful for reuse, and one of the things that make it even easier is that you can place it inside a reuse library. So for example, if I go to the location where the bracket template is stored, I can go ahead and add this to my library. And so if we come in here to the machine parts library and we go to our templates file, you'll see that the mounting plate is available for everyone to use. So anyone who has access to the reuse library will be able to use this part.